Good morning, Tehmina Khan is here. In this video, I am planning to explain the concept of domain and range of a composite function. Recently, few students told me that Miss, it's quite a complicated concept to understand and they were quite confused. So I decided to make a video on it. So let's just start with the basic questions and then 6 examples to find the domain and range of the composite function. So I have just picked up 2 points from the syllabus of the CIE because composite function is in the A-level mathematics P1, which is paper 1 mathematics. So the two concepts which I'm focusing in this video are how to construct composite function from two simple functions and then determine the domain and range of a composite function. So let's just start with the basic question. So consider two functions. One is f of x is equals to x plus 3 and g of x is equals to x square. So a new function f of g, which can be written as f of g of x. So it has the same meaning. Now this means that the function gx will be substituted in place of x in function f, right? It means this function will go in place over here. So this is what I'm going to do here now. You can see the function g of x is x square and I'm substituting in place of x here. So it will become x square plus 3. So my composite function f of g of x is x square plus 3. Similarly, if I have to find g of f of x, then function fx will go in place of x in function g, right? This is called first function or input function, and this is a second function. The input function f will go in place of x in function g. So in place of f of x, I can write the function itself, and then in place of x in function g, I'm writing this. It is acting as a domain for g. So this is my composite function. So this is how you construct a function, which is very simple, f of g and g of x, and it is also called a function of a function. So construction part is easy. So let's see one more example and then we will go into how to find domain and range of a composite function. Now for example, let's see this example. F of x is 2x plus 1 and g of x is root x. So in f of g of x, the function gx will go in place of x in f, in function f. So it will become this. And similarly, if it is g of f of x, this whole function will go here because now your input function is f of x, which is 2x plus 1. So now it will go in place of x here. So it will become root 2x plus 1. Now you can notice they are not same. So mostly f of g and g of x are not equal, but at times they can be equal as well. Because I remember first time when I was teaching this in one of the class, in my class, a student took it as f multiplied by g and g multiplied by f. So they thought it is same thing, whereas it is totally different. So do not consider that they will give you the same result. Okay, so now let's talk about, we are substituting some value in it. So my function fx is 2x minus 1 and the function gx is x square plus x plus 2. So first we will find out f of g of x and g of f of x. And after that we will evaluate. When we use the word evaluate, it means you will find the answer in number. And we will see what does this mean. G of f of 2, right? So now f of g of x, exactly the way I have just told you, the function g is your input function, which is here. It will go in place of x in function f. So it will become 2 times of this whole thing minus 1. And when we simplify, it becomes 2x square plus 2x plus 3, right? Okay, now we will find out g of f of x and then g of f of 2. Okay, so now g of f of x. It means input function is f of x, which is 2x minus 1, and it will go in function g, which is this. So in place of x here and here, this whole thing will come. So I have shown you the substitution here. You can see simplification, and I end up with this result. So this is my g of f of 2. Now if question says find out g of f of 2, there are two ways to do it. So one way is that you have just found out composite function g of f, which is this. So plug in 2 in place of x here, which I have shown here, right? And you got the answer 14. Now the second method, which is mostly appropriate, and I will tell you why when we will find out the domain and range. This method is more appropriate. First of all, I will find out f of 2. Now when I find f of 2, my answer is 3. It means the range of f is 3, and it will become the domain of g. I'm repeating. G of f of 2. 2 is a domain for f. I'm talking about second method. So I will substitute domain 2 in function f, which I have substituted here. And the answer 3 is actually the range of function f. Now this range will become the domain of second function, which is g. So you get the same answer, 14. So what did you learn? That the range or the output of first function become the domain of the second function. So now let's see the domain and range cases of the composite functions. Now the two functions given to you are these. I have taken 5-6 examples here to make the concept clear. So let's go slowly. For example, in here, function fx is 2x minus 3. Okay, I believe strongly on visualizing mathematics. So here I will visualize graph of the equations, right? Mostly it is simple, which you can visualize. Otherwise, for better understanding, when you are practicing, you can use Desmos. Desmos is a free online graphical calculator. It shows graph also. DESMOS. In exam, you will not be allowed, but definitely you will have a better idea. So anyway, so function fx is 2x minus 3. We know it is a straight line, and it is like this. And function g of x is equals to root x, and this is the graph. This is the prerequisite. There are certain graphs which we should know at this stage when we are appearing for P1, right? Okay, so now these are the two functions given to you, and you have to construct the composite function, and then you have to find out its domain or range. Domain and range, for example. Okay, so if I look at this function 2x minus 3, what does it show? That it is taking all the real values of x. Agreed? You can see it through graph also. Otherwise also you can see that this function can take all values of x. It is defined for all values of x. Whereas function g of x, which is root x, do you think it is defined for all values of x? What do you think? It is not. You know why? Because root of negative number will give you error. So this function is defined only for x greater than 0. So this is what I have written here, that your function f is defined for all values of x. So x belongs to real number. And the function g of x is only defined for x greater than equals to 0. Because otherwise root x, if it is negative, it will not exist. Now let's find out the composite function g of f. Now when I'm saying g of f, it means f is my input function, and it will replace x in function g. And in function g, x is here. So this function f will go in place of this. Now I have to find out the domain of this. Mostly the understanding of the student is where they get confused, that whatever is the domain of the input function, it will be the domain of the composite function. Now here it is a misunderstanding. Usually yes it is, but if there is restriction on the domain, then you have to be careful. You have to check, is it existing for it or not? Because the domain of the composite function, either the domain of the first function or it lies within it. Okay, so remember this thing. I will show you in writing also as a pointer a little while. Okay, so coming back. So now this is my function, right? And it has restricted domain. What is the restriction? That this 2x minus 3 should be greater than 0. Now, you know why I'm saying this. The point here is that my domain, my function g of x has domain x greater than 0. So I have to see that what are the values of my function f, which is 2x minus 3. What are the values of x which will give me output greater than 0? Because the output of function f is actually the domain of g. Yes or no? This is what we have seen in the previous examples. That for the function f, whatever is the output, whatever is the range of f of x will become domain of this. That's why I have put 2x minus 3 greater than 0. Because I want this result. 2x minus 3 greater than equals to 0. So it is giving me x should be greater than or equals to 3 upon 2. And the range of this composite function is only non-negative numbers. Because when you will put the values of x greater than or equals to 3 upon 2, greater than or equals to, it will be 0 or any positive number. So that's why the range is greater than or equals to 0. So in short, you can remember, we will see same thing again and again in different example. So 2 points you have to remember. In case of composite function, the domain is either the same point as the domain of the first function. This is my first function, or it lies within inside. So can you see this domain lies within the function domain of function f. What was it? It was saying x, let me show you again. It was saying x belongs to real number. So it lies within this. Iske andar aata, right? And second thing, the range of a composite function is either the same as the range of the second function or it lies inside. So these are two shortcut ways to remember it. But we will see logically again and again the same concept. So let's see example 2. Now in this example, the two functions fx and gx are these. F of x is 1 divided by x plus 2. I have shown the graph here for you. Sketch it, because I just told you visualizing mathematics is always a better understanding. And g of x is x divided by x minus 3. And we have to find out f of g of x. And then we have to find domain and range of the composite function. Now the first thing is, we have to see what is the domain of this. If it is not given in the question, you have to think with respect to the function, what is the domain? So if I see this is sketch, even if I don't say it, for example, I know x cannot be minus 2, because if it will be minus 2 plus 2 will become 0. And 1 divided by 0 will be undefined. So it means this function can take all values of x except minus 2. Agreed? Similarly, this function can take all values of x except x is equals to 3, because then it will be 3 divided by 0, which is undefined. So if you have to see the domain of these function individually, you can say the input function f of x can take all real numbers except x is equals to 3. This one, because this is my input function, I am going to substitute this function. So in composite function f of g, gx is your input function. So this function will go in function f in place of x here, right? And this is not defined for x is equals to 3, but otherwise it is defined for all real numbers. So domain is all real number except as x is equals to 3. Now the domain of f of x, I have already told you, cannot be minus 3. Okay. So now if we have to find out the composite function, which is f of g, right, and the output of g will become the input of f, right? So what are those values of x here which can give me result -2, because those answers I cannot take. I'm repeating what I have said. I have to find out the domain for the composite function. What I know is that output of this, when I will substitute different values of x, all the output of this will become the domain of this according to this composite function. So I am ready to take all the values of x, but I will not take that value of x which give me output -2, because I cannot take -2 as a domain here. So what I will do, I will put this function equals to -2, right? So that I know which value of x will give me result -2. So my composite function will not be defined for that value of x. I hope it is making sense to you that why did I put this thing is equals to -2, because this is function g of x and all its result output are basically domain of f. So I want to see which which x value will give me output -2. That I will not take. So let's see what is that. It is -2. So now the composite function has domain x belongs to real number, but it cannot be x is equals to 2, or it cannot be x is equals to 3. Now why did I write 3? Because in composite function, your function cannot accept the value of x for which input function is not defined. And we know x is equals to 3 is the value at which your function g of x is not defined. So that value and the other value for which the second function was not defined, we have taken both into consideration. And from here also you can see in the composite function, if you put x is equals to 2, it will become 0 and it is undefined. Now let's see another example. Now see this example. One function is -x, and you know function -x can take all values of x. Second function is g of x, which is ln x. Again it takes which values of x which are greater than 0. Reason is ln is not defined for negative values. So we can say that the domain of the input function, because I have to find out the composite function g of f of x. So my input function or my first function is f of x and my second function is g. So my input function is defined for all values of x, and my second function ln x is defined only for x greater than 0. So these two domains, even if it is not given in the question, looking at the equation, you can find out if it is simple equation, and otherwise domain will be given to you, restriction will be given to you there. Now the composite function is g of f of x. So my input function was f of x equals to -x. So it will go in g. Now it is ln -x. Now I know that ln is defined only for positive values of x. It means this is only possible if this whole thing is plus. And how come it is plus? If you take the values of x negative, for example -1 multiplied by minus will become +1. So that's why we said that for composite function the domain is x less than 0, right? So now see here. Therefore, using the restricted domain, we have x less than 0. G of f of x belongs to R, because this is my x less than 0 graph and it has all the values of y. So range is belonging to R. I hope many of you remember that the function ln x is like this, right? And when we take ln minus x, the graph is reflected in the y-axis. That's why it is like this. Let's see another example, which is example 4. So now let's see this example. The function f of x is sine x, sine graph. I know sine graph shape, I'll show you in a while. And gx is root x square. You have to find out the domain and range of g of f. Okay, so now if you look at the input function, f is your input function, it will go here, right, in a composite function. This is your second function, this is your first function, which is input function. So your input function is defined for all values of x, right? Sorry, for all values of x. Similarly, your second function, which is root x square, is also defined for all values of x. Reason is this square will always make a negative number positive. So root of a positive number exists. So the domain of both the function is x belongs to real number. Now we have to find out g of f of x. So my function f of x is sine x, and when it goes in place of root x square, it becomes sine square x. Now you might have done in the trigonometric chapter that the graph of sine is like this, and graph of sine square x is like this, and root of sine square is also very much like this, little bit difference, but the highest and lowest point is same. So now if you see here, the domain of g of x, g of f of x is real number, x belongs to real number. So in this example, the domain of the composite function is same as the domain of the first function, whereas in the previous two examples we saw that it was different. And the range is 0 to 1. So you can see the values of y on this graph are lying between 0 to 1. Let's see example 5. So two functions are these given to you, okay? And you have to find out the domain and range of function g of f of x. Now the domain of the input function, my f is my input function, this one. And we know from here it is a quadratic curve, right? So let me factorize it and see. Factors are 3 and minus 2. So graph has this shape, right? And it has domain x belongs to real number. Any real number is the domain. And the domain of the second function, which is g of x is equals to root x, is x greater than or equals to 0. Because this function is defined only if x is greater than or equals to 0. Now the composite function g of f of x is, I'm substituting function f in place of this here, in place of x in function g. I have substituted, right? Now, because this is true if x is greater than or equals to 0. So I will see what are the values of x for x minus 3 and x plus 2, which can give me result greater than or equals to 0. Because the output of function f is the input of function g, right? So that's why I need to put this greater than or equals to 0. And here my previous knowledge of quadratic inequality will play a role in it. And I got from here that for this inequality, x is less than or equals to minus 2 and x is greater than or equals to minus 2. You can see when it is saying greater than or equals to 0, it means the part of the curve which is above the x-axis. So this part, and the values of the x are here. So x greater than 3. And this part of the curve is positive, greater than 0. So these are the values. In case if you need to have a better understanding of quadratic inequality, you can check my other videos. Okay, so now, so in case of composite function, the domain is x less than equals to minus 2 or x greater than equals to 3. And what is the range? You know why it is this? What is the shape of this graph? Root x minus 3x plus 2. So it is an investigation for you. You can check, or you can find out the values on the Desmos and check it. So the range is y is greater than equals to 0. So last example, and I will do it little fast because we have done more or less same type of thing. So let's see. The function fx is x plus 2. Now this is a linear function, so it is true for the domain is for the values of x belongs to real number, all values of x. Whereas this function g is defined only if x is negative, or I can say when minus x is greater than 0. Okay, when this whole thing is greater than 0, only then the function is defined. So the domain of function fx is x belongs to R, and the domain of function g is x less than 0. So if I have to find the composite function domain and range, do not just write down that x belongs to R, which is a misunderstanding, that the composite function will have the domain, whatever is the domain of the input function. So let's see, it is the right case or not. It may or may not be. So let's see here. So function f is going here, right? You can see it is going here. I just simplified. Now this part need to be greater than 0, because if this will be positive, then root of positive number exists. So what did I end up at? That x is less than minus 2. So you see the domain of the composite function is less than minus 2, whereas initially the input function has x belongs to real number. So it may be different, but within that range. And the range is greater than 0, because whenever this will be positive, your answer of this overall function will always be greater than 0. So with this I end the video. I hope you would have understood the domain and range of composite function. If you have any query, anything not clear, you can ask a question in the comment and I'll try to explain it again. And you can press like and subscribe if you feel so, if you think the videos are useful and can help you. So very soon I will make other videos. Thank you very much for watching. God bless you. Take care.